Hello everyone, this is Jayashree and my teammates Keetna and Yogarani have done a project on speech recognition based vending machine using Hidden Markov Model. We are guided by Dr. V. Prabhu, Head of the Department and Assistant Professor of Electronics and Communication Engineering. These are the contents of our presentation. The main objectives of our project are to develop a vending machine that responds to voice commands, to design an efficient vending machine that uses Hidden Markov Model speech recognition algorithm, to extract the feature from the audio using MFCC algorithm, to cancel the external noise in the speech input using filter, to increase the performance of the vending machine and make it user-friendly. Introduction. Automated vending machines are increasing rapidly in metropolitan areas where a modern and fast-paced lifestyle necessitates high-quality products. Vending machines dispense items such as snacks, coffee, beverages, lottery tickets, and commercial goods. Design of vending machine using the HMM algorithm makes it user-friendly and a self-service device. Active noise cancellation involves reduction of disturbing noise without additional power consumption. This approach uses MFCC algorithm for accurate representation of spectrum envelope. We have also collected the literature review. Ticket machine queuing system design application for service efficiency simulation and comparison by Suvit Pumritugal and Amon Kumsubsri in the journal named International Conference on Electronics, Information and Communication in the year 2020 proposes the ticket machine queuing system design application with service efficiency such as the average delay in queue and waiting time of the customer. The inference of this proposal is that the delay and the waiting time is decreased in the queuing system. The next proposal is the development of smart unmanned vending machines using networked PLC and chatbots by Yu Shuang Huang, Zhenyi Chen, and Jin Shan Li in the journal named IEEE International Conference on Consumer Electronics in the year 2022 combines RFID, PLC, and chatbots to create a smart unmanned vending machine. The inference of this proposal is that it presents chatbots used on smartphones. The overall inference is that the existing models use buttons, touchscreens, chatbots, and other user interfaces or DTW-based vending machine. The accuracy of the system using DTW algorithm is very low. The proposed system uses speech signals as voice commands. The HMM algorithm combined with MFCC algorithm is more efficient than DTW for speech recognition. This system is very useful for visually impaired people. Speech recognition. Speech recognition is the process by which the speech signal is converted into text. This process is also called as transcription. Speech recognition works by using algorithm through a process referred to as language or acoustic modeling. Acoustic modeling is used to represent the relationship between the audio signals and the linguistic units of the speech. The challenges in speech recognition is that the human speech is characterized by different variables which vary from speaker to speaker. Example, the pitch, the way of pronunciation, the frequency, etc. The speech signal consists of both vowels and consonants. Speech signal is not stationary and the languages vary the speech. Dynamic time warping. The same or different speaker cannot have the same pronunciation twice even if it is the same word. The speech sample may vary in the size of intensity, spectrum offset, pronunciation, intonation, etc. Dynamic time warping works by comparing the points in time at which the two series are similar to each other. DTW compares the two time series that vary in speed, frequency, or other aspects. It uses graphical representation for analysis. The disadvantages of dynamic time warping is that its complexity, slower response times, vocabulary limitations, and sensitivity to noise and variability. The advantages of HMM is that it provides a statistical framework for modeling speech patterns. Training and adaptation is easier. HMMs can be combined with language models to improve the speech recognition accuracy and decoding flexibility. This is a simple block diagram of our project. The speech signal is taken as the input for the vending machine. This speech signal undergoes pre-processing, that is, it is resampled, the extension is handled, framed and windowed for making the signal stationary, and then filtered to remove the background noise. The features of the pre-processed signal are extracted and trained for HMM model. Thus, the speech is recognized and stored as pickle file. The processes involved in speech recognition are data collection, pre-processing, feature extraction, HMM training and decoding. Input. Audio speech signal is used as an input. Intensity normalization is applied to the audio to ensure that the order of presentation does not affect the CNN training performance. A microphone is used for getting the voice command input, and it is ensured that the audio is in .wav format. Data collection. The dataset can be taken from the internet source or can be made manually by collecting speech signals. Several samples of items found in the cart of the vending machine is fetched. The dataset is then classified into trained data and test data. Training set is used for training the speech recognition system and to estimate the parameters of the hidden Markov models. Test data is used to evaluate the performance of the trained speech recognition algorithm. Pre-processing. The general sampling frequency of the speech signal is 44 kHz, but for the vending machine's speech recognition, it is resampled to 8 kHz. It is framed to a size of 20 to 40 milliseconds and windowed using Hamming window of size 25 milliseconds. Active noise cancellation is done using a filter. Feature extraction. Mel frequency sepstral coefficients MFCC is used for extracting unique features of the speech samples. It represents the spectral characteristics of speech signals. It is proven to be effective for automatic speech recognition. MFCC process reduces the impact of irrelevant variations such as speaker and environmental differences. MFCC recognizes about 39 features. Some of the features include vocabulary size, language complexity, contextual information, etc. HMM training and decoding. HMMs are trained on a set of speech data to learn the statistical properties of the speech signal. This involves selecting an appropriate number of states for HMM, initializing the states, and observing the maximum likelihood. The speech signal is then decoded using trained HMM. It involves computing the likelihood of the observed features and selecting HMM with highest likelihood as recognized speech signal. Viterbi algorithm is used for efficient computation of likelihood and optimal state sequence.
Here is the result we obtained from our project. Before processing a dataset is split into training dataset or validation dataset. The purpose of splitting a dataset is to measure the accuracy of the HMM model. Generally, 80% of the dataset is used for training and the remaining is utilized for testing purpose. The figure D represents the graph of trained and tested data. Here, more data is utilized for training and remaining is utilized for testing. Figure E is the audio sample before filtering. Before applying filter, the speech signal consists of unwanted external noise which affects the quality of signal and also SNR value is affected. After applying a filter, unwanted components and noises are completely suppressed. Filtering always targets to improve the SNR value. Figure F represents the audio sample after filtering. By taking the advantage of filtering, background noises are successfully cancelled. The next obtained output is confusion matrix, which represents the number of samples and a predictive probability. The confusion matrix is also a error matrix, which tells where the error is occurred during prediction. The row of the confusion matrix represents the predicted values, while the column represents the actual values. The accuracy and precisions are accessed using this matrix. The higher the value of confusion matrix, the higher will be the prediction of the model. As per the confusion matrix obtained in our project, the model has recognized 49 products correctly out of 49. Expect the KitKat. Followed by dataset training, classification report is obtained. This table shows the detailed analysis of samples that can be correctly recognized and which cannot be recognized. This table is mainly used for calculating the accuracy of the model. The classification report shows precision, recall, F1 score, and support. Precision indicates accuracy of positive predictions. Recall measures completeness of positive prediction. F1 score is the harmonic mean of precision and recall. Finally, the support is the actual number of occurrences in the dataset. The figure I sketches the achievement of 92.3% of accuracy in training and 87.5% of accuracy in test data using Hidden Markov technique for recognizing speech. The speech-based vending machine's graphical user interface, which was designed using Python, is shown in figure J. This can work in two modes, speech command mode and button mode. The input mode can be selected to suit the needs of the customer. When a voice control option in the user interface is pressed, the machine inquires the customer preference and initializes the recording. Figure K illustrates how correctly the machine recognizes the spoken word even though the transcription of each word varies. The input coffee, maza and no are transcribed in 4 different ways. Using HMM algorithm, the correct word for the given input is recognized and transcribed correctly by comparing with the trained data set and obtained as a result. These are our references. Thank you.